Hello. Good evening, everyone. How are you? कैसे हैं आप लोग? So, fluid mechanics का today is the last lecture of fluid mechanics. This is going to be our last lecture. In this lecture, we will discuss about angle of contacts, capillarity rise, tube of insufficient length. So these are going to be the topics of the today's session. So we will wait for at least 2 minutes to join so that most of the students can join the session. Uh, till then, you can recall your previous concepts. In the previous class, what we have discussed about surface tension and the surface energy. So these were the two most important topics of the previous class. So try to bring your notes with yourself so that you can write everything that is being discussed here. I will give you some time so that you can write everything and make proper notes of everything. Actually, the notes are the most important thing, actually. If you have notes, then at the time of revision, it will help you out. Okay, then we are going to start our session. Hope you all are doing well with your studies. Okay. So first of all, we will discuss about angle of contact. This is a very confusing definition. If you read it out from the book, it might create a sort of confusion, uh, depending on the words of the language that the book is using. So let me describe it to you first. Okay. So uh, let me just remind you one thing or draw your attention to a one very simple phenomena that you can usually observe in your house, in your home, by a simple example. What I'm saying, if you take a glass of water, this is a glass of water, something, and if you place some water in it, if you pour some water in it, simply ordinary water. I'm not talking about completely pure water or kind of. I'm talking about normal water. So if you place it, so generally what we have an idea, what we generally think that water surface will look like a flat surface. But actually, what happens? The water surface is not as flat as you can see here. The water surface at the corners or the surface which is in contact with the glass just rises up a little bit. So this surface somehow looks like that. It, it achieves a concave shape actually. If you see closely, if you observe it very closely, you can see that this surface takes a nearly concave shape, and at the edges it just rises up in the glass of water, in the glass. So first thing, the first term that we are going to discuss is that this shape is generally known as meniscus. I'm not talking about that concave shape is called as meniscus, but this shape of the surface in a solid is known as meniscus. What it is known as meniscus. First thing is clear to you. Second thing, remember these words, meniscus. Second thing that we will discuss here, that what is angle of contact? What is angle of contact? Now you can see that there are two surfaces. One is liquid surface and one is solid surface. You can see that there are two surfaces. So what I'm saying, the angle between two tangents, angle of contact is what? Angle between two tangents. Now, one thing is clear in our mind, that angle of contact is going to be the angle between two tangents, and tangents are drawn on a surface. So out of these two tangents, one tangent is drawn on the liquid surface and other tangent is drawn on the solid surface. I'm just clearing the definition before displaying the actual definition. So what is angle of contact? Angle between two tangents. What are the two tangents? One tangent is on the liquid surface. This is our liquid surface. And another tangent is on the solid surface. Now, at which point you need to draw the tangents? At which point you need to draw the tangents? You need to draw the tangents at the point of contact. At point of contact. So I think definition part is clear. What is angle of contact? Angle between two tangents. Two tangents on what? One tangent on liquid surface, another tangent on solid surface. This is liquid surface. This is weaker is what? Weaker is glass. Glass is a solid surface. So these two tangents are one on liquid, one on solid. And at which point you need to draw the tangents? At the point of contact. Point of contact of what? Point of contact with the solid. I think everything is sorted now. So now I will display you the definition. You can read it out. Okay, so what the definition says, the angle between the tangents that is mentioned here to the liquid surface and the solid surface. So one is liquid surface, another is solid surface. At the point of contact, at the point of contact is called angle of contact. It is being denoted by theta. It is being denoted by theta. I think everything is sorted now. In the definition part is okay. Now, one more thing. Whenever you are talking about the angle between two tangents, then you have to decide the direction of the tangents as well. So the direction of the tangents is decided by the rule that's written here. Okay. What it says, I will describe it to you in more detail. Tangents or tangent on the solid surface should be towards the liquid. Should be towards the liquid. Clear? And tangent on the liquid surface, you are drawing two tangents, one on solid surface. So the tangent that is going to be drawn on solid surface should be directed towards the liquid. And the tangent which is drawn on the liquid surface should be drawn away from the solid. Should be drawn away from the solid. Okay, now I will draw some tangents for you. I will draw some tangents for you. Okay, listen to me. So I have mentioned three terms. One is meniscus. What is meniscus? The shape of the surface. What is meniscus? Shape of the surface. Shape of liquid surface is known as meniscus. Second thing, angle of contact. It is denoted by theta, the angle between two tangents. After that, how the tangents are drawn, one on solid surface, one on liquid surface. The solid surface, the tangent on solid surface is drawn towards the liquid like this. Now, have a look at that. Let's suppose this is a container or a beaker something, and this is liquid filled in it. This shape is generally known as concave shape, and generally you can call it as meniscus. You can call it as meniscus. Now I am going to draw the tangent on the liquid surface. Keep this thing in mind. Where you have to draw the tangent at the point of contact. So this is the point of contact, you can see. So tangent on the liquid surface is drawn where? Away from the solid. So this side is solid. This is solid. and this is liquid. So away from the solid, you can draw a tangent. So I have drawn a tangent. This is a tangent on the liquid surface. Clear? Now, second tangent I have to draw. Second tangent is on solid surface, which is towards the liquid. If you think that this is our solid surface, if you draw a tangent at this surface, the tangent will be something like that. Can you see the tangent here? If you see the tangent, either you can draw the tangent here as well. But this tangent is not, you can see that is not towards the liquid. It's away from the liquid. So you need to choose the tangent which is towards the liquid. So this is towards the liquid. So I am deleting the above tangent, this tangent. I think the most important line is clear. When you draw the tangent on the solid surface, it should be towards the liquid. So it should be towards the liquid. And the angle between these two tangents is called angle of contact. Is called angle of contact. So it is theta. This is angle theta. Now I am drawing the angle of contact, the tangents for one more surface, which is also very common, like this. This is what? This is again a liquid, and but this time the shape is convex. Shape is convex. So I am drawing again the tangents. Tangent at the point of contact. This is point of contact. Tangent on the solid surface is this one towards the liquid. Tangent on the liquid surface is this one. This tangent is away from the solid. This is solid now. So this is away from the solid. And this angle is known as angle of contact. So I hope you can draw the angle of contact. I hope you can draw the angle of contact now. So now you can remember few things. You can remember few things. We will make some punchlines from this discussion. What you can see that this is a concave surface now. This is convex. So what you can see that for a concave surface, angle of contact is less than 90. This angle you can see is less than 90. And for convex surface, angle of contact is more than 90. Angle of contact is more than 90. One more thing you can see here, that if angle of contact is less than 90 in this situation, in the first case, angle of contact is less than 90, then the liquid is rising. Liquid is rising in the tube. Like at the edges, you can see that liquid is rising. And if liquid is rising, can you imagine that liquid is just sticking to the water, sticking to the surface of the solid. Liquid is sticking to the surface of the solid. So this property is known as wettability. This property is known as wettability. Wettability. So you can see that, or you can mention that here, more wettability. I don't know whether I am writing the correct spelling. Wettability means, if I talk it, wettability in Hindi, it is, you can say that सरफेस को सॉलिड की सरफेस को गीला करता है. गीला करता है मींस उससे चिपकता है. It clings to the solid surface. And in this case, you can see liquid is not rising, it's just falling. And if it's just falling, you can see that it's not sticking to the solid surface. So less wettability. When less wettability, if theta is more, wettability will be less. So you can make a sense in your mind that if theta is more, wettability will also be less, will be less. Also, no, will be less. So they are reciprocal things. If theta is more, wettability is less. If theta is less, wettability is more. I think clear. Wettability is what I think you are getting my point. What is wettability? The water or the liquid clings with the surface of the solid. It is called wettability. I think there are too much things on this single slide. So I will move further. So there are few punchlines. For the liquid that rises in contact with a solid. Now, tell me whether it is the first case or the second case. Is it the first case or the second case that we have drawn earlier on the previous slide? So this is the first case. You can see that liquid rises in the contact with a solid. Now, then what will happen? That means theta is less than 90. That you have learned. Theta is less than 90. Or you can see it as reverse. If theta is less than 90, then liquid rises in the solid. Another thing. Meniscus will be concave. That's another point. Now, for the liquid that falls in contact with a solid, this is our second case. So from second case, what you can see, theta is greater than 90. You can see it also as reverse process. If theta is greater than 90, that liquid will fall. Meniscus will be convex. So here you can also add wettability is more. And what you can add here, wettability is less. Okay, now I think you can, okay, tell me. This is a container, okay? So you need to tell me the shape of the meniscus. I am saying that theta is 30 degree. Tell me the shape of the meniscus, whether it will be concave or convex, whether liquid will rise or fall. Theta is what? Angle of contact. If angle of contact is less than 90, angle of contact is less than 90, then liquid will rise in the solid. So shape will be concave. Shape will be concave. Clear? Okay. Moving further. There are some standard values that for a pure water, if you want to remember, for a pure water with clean glass, the angle of contact is 0 degree. You can remember this thing. You can remember the fact actually. This is a fact that for pure water with glass, with clean glass, the angle of contact is 0 degree. If the angle of contact is 0 degree, then wettability will be what? Wette will be perfectly wettable. It will perfectly wet the surface because lesser the angle, more will be the wettability. I think till now everything is sorted. Angle of contact, concept of angle of contact is sorted. Now, moving further. Okay, it is mentioned here. I think you can see that for pure water and glass, angle of contact is 0 degree. Angle of contact is what? 0 degree. Moving further. So I can mention the term here, wettability is less. Okay. Now, the next topic is capillarity. What is capillarity? There are a lot of phenomena based on this simple concept. Lot of real life phenomena are there. So first thing is, what is capillarity? Okay. Capillarity is what? Have you ever seen uh, when a narrow tube is inserted, is dipped in a liquid? When a narrow long tube is inserted in a liquid, sometimes liquid rises in the tube, or sometimes liquid falls in the tube. So this rise or fall of the liquid in a tube, in a narrow tube, is known as capillarity. You are not listening to me. What I am saying, when a narrow tube means thin tube, is dipped in a liquid, then sometimes liquid rises in the tube and sometimes liquid falls in the tube. So this rise or fall of the liquid in a narrow tube is known as capillarity. Definition is on your screen. What it says, the rise or fall of a liquid in a narrow tube placed in a liquid filled container is called capillarity, and that tube is called as capillary tube. That tube is called as capillary tube. So what are the examples you can see? Uh, I don't know if someone of you is kind of uh, uh, what it says, जो पूजा करते हैं, दीपक जलाते हैं, kind of. You know that when मम्मी लोग पूजा करते हैं तो they usually एक दीपक जलाते हैं. तो उस दीपक में एक कॉटन होती है, उसमें घी डालते हैं हम लोग, एक एक कॉटन से हम लोग एक वो बनाते हैं ना, जो जलती है. तो वो जब हम पूजा करते हैं तो वो जो दीपक जल रहा है, उसमें जो घी हम बर्न कर रहे हैं, दैट घी, दैट ऑयल, दैट राइजेस, दैट्स ड्यू टू दी कैपिलरिटी राइज. इन दी फार्म्स एक्चुअली, आई डोंट नो द इंग्लिश टर्म एक्चुअली, जो हमारे फार्म्स होते हैं उसमें क्या होता है अक्सर, यू नो, द ट्रैक्टर थिंग. I don't know whether you know about these things or not, because these are the very common things in my region. So the tractor thing, क्या करते हैं, खेत में हम लोग ट्रैक्टर से पूरा खेत बिगाड़ देते हैं, उसको उसको हम लोग, आई डोंट नो द एग्जैक्ट मीनिंग, एग्जैक्ट टर्म, आई थिंक फ्लोइंग ऑफ द फार्म बोलते हैं उसको, आई डोंट नो. सो अगर ऐसा नहीं करते हैं हम लोग, तो उसमें क्या हो जाता है कि बहुत सारी छोटी छोटी ट्यूब्स बन जाती हैं मिट्टी के अंदर. इन दी सॉइल देयर आर लॉट ऑफ स्मॉल स्मॉल नैरो नैरो ट्यूब्स आर फॉर्म्ड. थ्रू दीज ट्यूब्स लिक्विड इवेपोरेट्स, liquid rises and evaporates. So this is the loss of capillary. So we flow the farms to break these capillary tubes. uh, I think you know the terms. Okay. So what is capillarity? I have described it to you. Now listen to me very carefully. There may be two situations. In one situation, liquid may rise. In one situation, liquid may fall. So in which situation liquid may rise, that we have learned already, when angle of contact is less than 90. When angle of contact is less than 90, then liquid will rise in the tube. Then liquid will rise in the tube. And if angle of contact is more than 90, then liquid will fall in the tube. Here you can see that this is a container which is filled with a liquid and a tube is inserted in it. A tube is inserted in it. This tube is inserted. And you can see that liquid is rising. Liquid is rising in contact. So that's why angle of contact is less than 90. If angle of contact is less than 90, then liquid will rise in the tube up to a certain height, whatever may be, but liquid will rise up to a height. And in the second case, you can see that here the liquid is falling. Meniscus is convex. So theta is more than 90 here actually. Theta is more than 90. In that case, liquid will fall in the tube. But both these phenomena are known as capillarity. Both these phenomena are known as capillarity. In this situation, liquid has fallen. In this situation, liquid has risen up to a height. Clear? Okay. Okay. So moving further. So what we will describe now, we will describe how much this liquid will rise or how much this liquid will fall in the tube. Okay. So again, this is the same diagram. Let's suppose the liquid has risen to a height h, and this height h is taken from the surface of the liquid in the container. And also suppose that r is the radius. Let this tube has a radius r. Radius of tube. Clear? So this is the radius of tube. Then what will be the formula of this rise? You can remember this formula. There is no need actually to. This is due to the pressure difference. Actually, the rise is due to the pressure difference, but we don't need to drive the formula. You have derived it in your NCRT book, or you can drive that from your NCRT book. So there is no need. What is the capillarity rise? What is the formula for that? H is equals to 2p cos theta divided by r rho g. So I will describe each and every term here. We have defined r already. R is what? Radius of the tube. Mark my word. This is radius of the tube. Now, T is the simple word. You all know that T is what? Surface tension. T is what? Surface tension. Theta is what? Angle of contact. Rho is what? Density of the liquid. And R is what? Radius of the tube. Now, this is the basic thing. Now, there might be a question, there might be a situation in which this capillary tube is not vertical. It is inclined at a certain angle. Then what will happen? Then what will happen? That is the question. Okay. So I will describe it here. What is the situation if tube is not vertical? If tube is not vertical. Okay. What will happen in this situation? Then the situation may look like something like that. This is the capillarity tube, and this is not vertical, and some liquid is filled in it. So one thing, liquid will rise in it. That's for sure because the angle of contact is less than 90. The another most important thing, this H in this relation, this H in this relation is the, or I can write it here, H in this relation is vertical height. So, however you may tilt the tube, the vertical height of the liquid will remain same. What I am saying, the vertical height of the liquid will always remain same. You need to remember this thing, that this vertical height will remain same. It will remain h. Whatever, how much you may tilt it, but this vertical height will remain same. So what will change? The length of the liquid in the tube will change. The length of the liquid in the tube will change. So what are the punchline, or what is the punchline? Vertical height of liquid in the tube will remain same. Only the length of liquid in the tube will change. I think all these things are clear. This height will remain same, only the this length of the liquid will change. Okay. In this situation, height and length both are same. If this is the length of the liquid in the tube, then this H is equals to L. But in this situation, H is not equals to L. Nothing else. So I am not calculating the value of L here because it will depend on the angle of inclination, angle of by which it is inclined. It is inclined from vertical. The angle is given from vertical or from horizontal. So it will depend. So we will solve it out. We will solve it out using an example. So right now, you need to remember one or two things here. What is the formula for capillarity rise? That is 2t cos theta upon r rho g. R is what? Make sure in your mind that small r is what? Radius of the tube. Radius of the tube. There might be another term. There might be another term mentioned as radius of meniscus, because this is a surface. This is a surface. This is concave surface. So it might have some radius. It might have some radius. So that radius may also be given. We will drive a relation for that. But right now, this formula is valid for R is radius of the tube. So we will move further for let's take an example. Let's take a concept test. Concept test is on your screen. You have 40 seconds to solve. I'm waiting for 40 seconds. Don't get confused with the question. Okay, what the question says, there are three liquids of densities rho 1, rho 2, and rho 3. Okay. And the given thing is that rho 1 is greater than rho 2 is greater than rho 3. Clear? Okay. Having same surface tension T, same surface tension T rises to the same height. Okay, everything is same, rises to the same height in three identical capillary tubes, three identical capillaries. I think there should be capillary tubes. The angle of contact theta 1, theta 2, and theta 3 obeys. There are four relations mentioned here. So you need to take one correct relation. Okay. Okay. So they are talking about capillary and the height of the rise is same. No issue. What we know that what is the formula for height of or rise in the capillary tube? H is equals to 2t cos theta divided by r, rho, and g. Clear? So now mention or identify the things which are same, which are identical for all three liquids. You will see that you will see that same surface tension. That means T is constant. Okay. And another thing is same height. That means H is constant for both for all the three liquids. Another thing is G is universally constant. No issue with that. And identical capillaries. Identical means radius of the tube is also constant. And 2 is you know that universally constant. So now what I can see that all these circled things, circled quantities are constant. So what you can see here, you can conclude from this relation that cos theta is proportional to rho. This rho will get there. You can see that rho will move there and all other terms are constants. That means cos theta is proportional to rho. And it is given that rho 1 is greater than rho 2 is greater than rho 3. That means rho 1 is highest. So corresponding angles are theta 1, theta 2, theta 3. So you can mention that cos theta 1 is greater than cos theta 2 is greater than cos theta 3. So this is the relation between the angles, but this relation is in a function of cos theta. But they are asking the normal cosine function, normal theta function. What is the relation between angles theta? So cos theta is a decreasing function. Cos theta is a decreasing function. So what I will write cos theta is a decreasing function. What does it mean? If cos theta 1 is greater than, that means theta 1 will be smaller. So you can mention, you can write here theta 1 is less than theta 2 is less than theta 3. So right now this relation is we have what we have got. And this is for two options C and D. Theta 1 is less than theta 2, theta 1 less than theta 2, clear. So now we need to find the angle. Now again you can see that liquid is rising. Liquid is rising. Liquid rising. When liquid rises, when the angle of contact is less than 90. That means the maximum angle theta 3 should be less than 90. Acute angle, it should be acute angle. That means it should be greater than 0. So the correct option is C. Clear? I hope it is clear. Moving further. I hope you got this. Moving further. Water rises in a vertical tube. Okay. This is again a 30-second or 40-second question. I will not give you more than 40 seconds for this. Okay. So the question says, water rises in a vertical tube up to a height 2 centimeter. Okay. So H is given as 2 centimeter. If the tube is inclined at an angle 60-degree with the vertical, 60-degree with the vertical, then up to what length the water will rise in the tube? Okay. No problem. We will draw the diagram. The situation is like that. Tube is inclined at an angle 60-degree with the vertical. Okay. You can see that. You can see that tube is inclined at an angle 60-degree from the vertical. Okay. Let's suppose this is the water filled in the tube. And this is water rises. The one thing is that when water rises up to a height 2 centimeter, this height, this H is what? Vertical height. This H is what? Vertical height. This is the vertical height given. This is 2 centimeter. Or you can see that this height is 2 centimeter in the diagram. This height is 2 centimeter and this length is being asked. Let this length is L. Clear? If this angle is 60, then this angle will be 30. This angle will be total is 90, na? Horizontal and vertical. So this angle will be 30 degrees. So from this right angle triangle, you can see that H is equals to L sine theta. H is what? Perpendicular. Perpendicular is what? Hypotenuse into sine theta. Theta is what? 30 degree. So H is given as 2 is equals to L we need to find out. Sine theta is what? 1 by 2. So L is equals to what? 4 centimeter. This is a very simple question. So option D is the correct option. I think it is clear. Moving further. Try to solve out these questions. Try to make notes of these questions in the first 40 seconds. If you are not attempting the question, at least try to write down the question. Because at the end of the day, you will have to find something for the revision. Okay. Moving further. Now, relation between radius of the tube and radius of the meniscus. What we have discussed previously when we were discussing the rise formula, then the radius of the tube is used. Now, in some questions, you may find that they have given radius of meniscus. Okay. So in this diagram, you can see this white lines represents a tube. These white lines represent a tube in which liquid is rising. And the shape of the meniscus is concave. Shape of the meniscus is concave. And I have just completed the circle of the meniscus. So this is not the actual circle. This is the completed portion that which I have completed. Or you can see that I have completed it like that. You can see it. Let's suppose the radius of meniscus is capital R. Clear? Okay. And the angle of contact is theta. Angle of contact is theta. So let me draw actually some tangents. You have seen that at the point of contact, this is the tangent on the liquid surface, and this is the tangent on the solid surface. Clear? And this angle is going to be theta, angle of contact. Clear? Till now, everything is clear. Now, I am drawing, let's suppose this is the radius of the tube. This is the center of the tube, and this is going to be the radius of the tube, small r. Clear? Now, where is the center of this meniscus circle? Let's suppose its center is here. So it will be the radius of this meniscus, that is capital R. Okay. Now, we need to find a relation between these two. This radius is small r. Now, we need to find a relation between these two things, two radiuses, actually. Okay. You know one thing, that tangent is always perpendicular to the radius. Tangent is always perpendicular to the radius. That means this total angle, I will delete all the angles that I am drawing. This angle is 90 because this is the tangent on the liquid and this is the tangent of the meniscus. So both of these should be perpendicular. In the same way, this is the radius of the tube and this is the surface of the solid. So this angle is also 90. From this conclusion, I can conclude that if I remove everything, every dirty thing from here, what you can conclude that the angle between these two things or these two radiuses will be theta. Will be theta. From the simple geometry. From the simple geometry. Clear? Okay, if this angle is theta, then again I am saying, what is the value of cos theta? Cos theta will be base over hypotenuse. Base is what? Small r. Hypotenuse is what? In this right angle triangle. Hypotenuse is what? Capital R. So this is the relation you can see, or you can see R is equals to capital R cos theta. Clear? Whatever you may use, you may write it as R is equals to small r upon cos theta. Whatever you may write, but the relation is this on your screen. You can use either of the relations. So what are the terms here? I will mention all the terms here again. Small r is what? Radius of tube. Capital R is what? Radius of meniscus. And theta is what? Angle of contact. Clear? So the relation between them, small r is equals to capital R cos theta. R is equals to R cos theta. Remember at least one of them. Clear? Okay, moving further. Now the situation is tube of insufficient length. This is again an important question. Mostly questions come from it. Tube of insufficient length. What if I say that from the calculation of the formula, from the calculation of this formula, you have calculated that height of the rise is 10 centimeter. Fine, let's suppose you have calculated that the height of the rise is 10 centimeter, but the length of the tube is just 7 centimeter or 8 centimeter. Then what will happen? Then what will happen? So what will happen if the tube is of insufficient length? Insufficient, there should not be a space. Then what will happen in this situation? The radius of meniscus will increase. The radius of meniscus will increase, but water will not fall actually, but the radius of meniscus will increase and liquid will not fall. Now, let's assume, let have you got this relation? R is equals to R cos theta. So let me decide one more thing. What is H then? H is equals to 2t cos theta divided by R rho G. If you place the value of R, so it will become H is equals to 2t cos theta divided by R is what? R cos theta rho into G. Cos theta will be cancelled out and H will be 2t divided by R rho G. So this relation is in the form of radius of meniscus. This relation is in the form of radius of meniscus. I think every point is clear till now. You can ask if you want to ask. Okay. So tube of insufficient length, what I am assuming, I am assuming H1 is the calculated height. The height you have calculated from the formula. And H2 is the actual height of tube. And the condition is that H2 is less than H1. Only then it will be an insufficient length tube. So H2 is less than H1. Now, you know that height of the tube is what? 2t upon R rho G. This R is what? Radius of meniscus. This R is what? Radius of meniscus. So H is equals to 2t upon R rho G. What are the terms? Constant. What are the constant terms? You will see surface tension for the liquid. Liquid is same, na? So surface tension will be same. G will be same. Rho will be same. 2 is same. I think it is clear now. Everything is same. So can you see that if I transfer R here, so H into R is a constant because all other things are constant now. These red circles are what? Constant. So H into R is a constant. Or you can see that, or you can write it as H1 R1 is equals to H2 R2. That means whenever tube of insufficient length is used, the product of H into R will remain constant. Product of H into R will remain constant. That's a very good relation. H into R will remain constant. Now this relation can be transformed in another form as well in terms of angle of contact. How? You can see that what you can see that R is equals to R upon cos theta. R is equals to R upon cos theta. You can see that. So now we can see that H into R can be written as R upon cos theta is a constant. Again, this R is the radius of the tube. You can't change the radius of the tube. Radius of tube will remain constant. So what will happen? You will see that H upon cos theta is a constant. So H upon cos theta is a constant means H1 upon H2 is equals to cos theta 1 upon cos theta. This is another relation where theta 1 and theta 2 are the angle of contacts. That means whenever tube of insufficient length is used, what changes? The radius of meniscus changes, and the if radius of meniscus is changing, then the angle of contact will also change. So only two things will change. What are the two things? Angle of contact and radius of meniscus will change. And for all these calculation, you need to use these two formulas. Or you can remember H into R as a constant, and you can remember H is proportional to cos theta. Remember either of the relation or both of the relations. Now moving further for a very quick concept test. The question is on your screen. Try to solve it out very quickly. You have 30 seconds, 30, 30, 35 seconds. You can take 40 seconds as well. Do it quick. Okay. Let's solve it out. Okay. So question says liquid rises to a height of 2 centimeter in a capillary tube. That means it can rise up to a height of this is what this is calculated height 2 centimeter in a tube, and angle of contact is 0 degree. Clear? If the tube is depressed now, if the tube is depressed now, tube is pushed further in the liquid, depressed now, so that top of capillarity is now only 1 centimeter above the liquid. So this is the height available of the tube, actual height of the tube now. So this is 1 centimeter. Then the apparent angle of contact will be. So angle of contact, they are dealing in terms of angle of contact. But I have told you that remember H is proportional to cos theta. H is proportional to cos theta. So what will be H1 over H2 will be cos theta 1 over cos theta 2. H1 is what? Calculated height. Calculated height is what? 2 centimeters. So I will place the value 2 centimeter divided by H2. In now available height is 1 centimeter. I am not changing because centimeter will cancel out. Initial angle of contact is cos 0. Final angle of contact is asked. So you can see cos 0 is 1. So cos theta 2 will be 1 by 2. I think cos theta 2 is equals to 1 by 2. So theta 2 is equals to cos 1 by 2, cos inverse 1 by 2. I think 60 degree. It's not that I think, it's actually 60 degree. The correct option is 0, 30, 90, 60. Correct option is C. I think it is clear. So the chapter is completed now. You can practice the question from either of the book, from SC Verma itself. You can practice. You can also practice your NCRT exercise because direct questions are coming from NCRT. The I don't think there is an issue with anything left behind. If you have any doubts, you can ask me out. So I'm ending the session till now. I hope you have enjoyed the lecture, you have enjoyed the chapter. I'm ending the session. Till then, goodbye.